Now that we have paid some attention to various possible goals of natural resource management, let us delve deeper into the practice of valuation. This overview figure by Costanza and co-authors depicts the various types of ecosystem services in a systems model. It illustrates that ecosystem services provide benefits and value that is co-produced in interaction with built human and social capital. The study by Costanza et al. 97 that kicked off much of the ecosystem service literature recognized 17 different ecosystem services. The review paper shows that there exist alternative classifications as well, but that these alternatives also span 4 broader categories. This figure shows 19 ecosystem services, also in these 4 categories of provisioning services, regulating services, cultural services, and supporting services. Costanza et al. Point out that the value of provisioning services is easiest to estimate, often by using information from markets. Regulating services and indirect value supporting services have more of a public goods nature, and cultural services could be considered a mix. This makes it more challenging to come to value estimates. Costanza and colleagues provide some defense for taking this pragmatic position to monetary valuation of nature. Quoting their 1997 article, page 255, although ecosystem valuation is certainly difficult and fraught with uncertainties, one choice we do not have is whether or not to do it. Rather, the decisions we make as a society about ecosystems imply valuations. We can choose to make these valuations explicit or not, but as long as we are forced to make choices, we are going through the process of valuation. So how do we determine what value to give to nature and public policy? Or how do we determine what share of land to protect for future generations? When estimating values of nature, it makes some sense to distinguish between types of value. This figure from the economics of ecosystems and biodiversity shows which methods can be used to estimate which types of value. I focus on the preference-based approaches here. Naturally, other methods such as replacement cost methods and material flow analysis can also provide valuable input. The first distinction is use and non-use values, where within use values we can further distinguish between direct and indirect use, or another often made distinction is between consumptive use and non-consumptive use of nature. An example of the former would be fishing for consumption, while the catch and release sports fishing or scuba diving would be examples of the latter. In case of consumptive use, we often take the price of natural resources as a proxy for its value. However, valuation is more difficult in the case of non-consumptive use, because enjoyment from national parks is often free. A first valuation method relies heavily on a suggestion by Hoteling. For one of the most used of Hoteling's economic insights, I will rely on a summary of Arrow and Lehman, because it is contained not in a paper but in a letter to the director of the National Park Service. The director had asked him and others how to measure the economic value of national parks. Since the entrance fee is relatively small, it is clear that people are probably getting satisfaction from the park well in excess of the fee charged. Hoteling noted that people usually have to travel considerable distances and thereby incur significant money costs. If we find the largest distance traveled, then those individuals can be thought of as getting zero net satisfaction, the value of the park less the transportation costs. Then all nearer individuals get a surplus that can be computed. By integrating over the population, we can get a total measure of satisfaction. This method, called the transportation cost method, has been used numerous times to evaluate the social gain to parks and similar geographically defined sites. Let us consider a hypothetical park, where this example is taken from Perman and colleagues. The park authority kept visitor records depicted in this table by distance from the park. A First step in estimating the park's value is by finding a relation between the number of visitors and travel costs. Let's say we can estimate such a relationship with the help of a ordinary least squares to control for other observable characteristics. And suppose that this procedure gives us park visits as a function of travel cost specified as 10,500 visits minus 300 visits per dollar travel cost for this example. Now, in a second step, we take our estimated relationship, add a hypothetical ticket price, and estimate for each hypothetical ticket price how many people we would expect to visit the park. In doing so, we create a demand function for park visits depending on these hypothetical ticket prices. All we need to do next is integrate over this demand function to determine the consumer surplus of the park. In this example, this procedure suggests a park value of a little over $1 million, in case you want to check. The idea behind the travel cost method has also been applied to using differences in housing prices to obtain estimates for the value of proximity to nature. These methods go by the name of cost methods and hedonic pricing. While the travel cost method may help us to get some estimate for the recreational value of natural capital, the method has important limitations. For example, estimates depend on what one assumes for the opportunity cost of time, how one treats distance to other parks that may serve as substitutes, or how one treats combined visits. It is also good to keep in mind that the travel cost method can only give estimates of parks their recreational value. That is, it is unable to capture non-use value or intrinsic value. For example, I've never visited the Great Barrier Reef, yet I attach value to its health. Or in terms of bequest value, I may never get to see a tree kangaroo in person, but I value that my nephew could still do so one day. For these type of non-use values, we cannot use revealed preference studies. So rather than looking at behavior, scholars try to obtain value estimates from stated preferences. However, talk is cheap, so how can estimates based on it be valuable? As a more extensive introduction into contingent valuation, I recommend both an early criticism on the method by Diamond and Hausmann and a relatively recent literature review by Kling, Vanev and Sau. This literature review highlighted that there were only about 50 studies that used the contingent valuation method until the late 80s, and that this number has exploded to several thousands since the Oil Pollution Act decided that passive use could be included in formulating the damages in the Exxon oil spill. Not long thereafter, the United States, their National Oceanic and Atmospheric Administration, established a high-profile panel, including Arrow and Soloff, to discuss best practices for such contingent valuation studies. Kling et al. Reviewed these best practices and prescribe using a referendum format, where participants can respond to a posted price for a policy, preferably expressed using a familiar payment mechanism, for example in terms of a tax increase. It is also advised to describe the policy under evaluation as specific as possible, possibly including photos, videos, or graphs comparing the status quo with the proposed policy intervention. The response to a single price also has some drawbacks. The binary outcome variable is less informative than what one could obtain using choice experiments or price lists. In either case, it is a good idea to pre-test the posted prices with the focus group and to include comprehension questions for checks during the experiment. Diamond and Hausmann point at some problems with the contingent valuation method. First, using studies that combined contingent valuation with verbal protocol analysis, that is, studies that asked participants to think out loud about the questions, revealed that rather than thinking about how much participants valued a certain natural area or species, most participants expressed a general concern for the environment or what they thought that they and other participants should do. As a result, comparisons of the resulting willingness to pay from these contingent valuation studies sometimes make little sense. For example, willingness to pay is often hardly responsive to scope, with willingness to pay for cleaning up one beach being nearly equal to that of cleaning up multiple beaches, including the single beach. Or a second problematic outcome has been that the valuation to save seals depended on whether the question was asked before or after a similar valuation question about saving whales. Other problematic findings for the method are that the willingness to pay depends on the payment mechanism used and source of the problem. At the same time, whether you see something as a problematic feature of a method also depends on the theoretical lens from which you review its validity. For example, Diamond and Hausman hold it against the contingent valuation method that the willingness to pay for a policy occurring is often not the same as the willingness to accept payment for a policy not occurring. However, this observation is only problematic from their neoclassical economics lens. From a behavioral economics, we recognize this difference as the endowment effect. Kling et al. Are more favorable about the use of contingent valuation, based on their review of the literature against different validity criteria. When contingent valuation outcomes are checked against outcomes of actual referenda and experiments with real stakes, meta-analyses find evidence of overstating in contingent valuation with a mean hypothetical bias of 35%. Yet the estimates correlate with those obtained using revealed preference methods. And when contingent valuation explicitly excludes non-use values, it has been shown to produce underestimates. By contrast, Diamond and Hausman contend that when contingent valuation measures beliefs rather than preferences, that policymakers would do better acquiring expert opinion. To value or not to value? That is not the question. Callas, Gomez, Bahatun, and Sografos argue that it will be more fruitful to ask how, when, and under what conditions we should provide monetary value estimates for ecosystems or natural resources. Now that we have looked into the how, let us also consider when and under what conditions. Quoting from page 100, before deciding whether to accept a monetary value on a resource or ecosystem service, one has to ask, 1. Will that improve the environmental conditions at stake? 2. Will it reduce inequalities and redistribute power? 3. Is it likely to suppress other languages of valuation and value articulating institutions? 4. Will it serve processes of enclosure of the commons? The latter two criteria express the fear that monetary valuation may serve as a first step in the process of further exploitation of nature or people by either drowning out other considerations than money in trade-offs, or by facilitating the process of privatization and extending the neoliberal reach. Costanza and colleagues list a number of uses for ecosystem valuation that may satisfy these criteria. Their Table 5 includes awareness, national accounts, and policy evaluations as potential applications. Full cost accounting refers to providing estimates of external costs. The paper refers to the project True Cost that identified external environmental costs by sector regions. Here I have included Table 2 from their study that shows that the sector regions with the highest external costs overall. For each of these sectors, their external impact outweighs their revenues generated. Were so for cattle ranching and farming in South America. Another application of ecosystem service valuation is to serve as an input to set up common asset trusts. Common asset trusts transfer the management of public assets to communities or collectives and A related paper by Costanza shows how the design principles from Ostrom are being applied to formulate such common asset trusts.